Suppose you are training a system to summarize something. Till training, you can apply the teacher forcing because you have a ground truth with your data. But in test, suppose you consider just try to think on test case. Do you have a ground truth? In test case, we generally take the input. So we will have an input document, not its summary in our hand. Because we are going to calculate the summary. We cannot use the summary from anywhere else. So in that case, we don't have that kind of teacher forcing kind of things. Teacher forcing input. So if we don't have teacher forcing input, then what we will do? We will use the previous output as an input to the next level in the test process. Training process is fine, but in the test process we will use this. And as we don't have this in the test process, so it will totally destroy the system. Several times it will totally destroy the system. And this condition is known as exposure bias. So this is a serious problem. Now, suppose exposure bias happens, then how we can solve this problem? Means how we can avoid the situations of exposure bias. So you can think how we can do that. Means teacher forcing is required. Means it helps. You understand that it helps at some level. But at a later stage of training, in the same model training, if we remove that support and make the model independently learn without teacher, means they start learning with teachers with some condition, and after that it will automatically learn without teacher, then system will be capable to learn without teacher forcing and will have almost similar advantage of teacher forcing, and we will not have that dependency, blind dependency of teacher forcing kind of thing in the trained model. Then I think it will solve the problem. And the similar thing is already there. So for that you have to go through this paper. I will give that in the description box. I will give the previous teacher forcing paper also in the description box, so you can use it. So in that paper, how they solved the problem of teacher forcing. So what they did, here the same kind of RNN architecture is represented like in the paper that covers the first block, and after that last two hidden layer blocks they have used to explain their concept. So the concept is same like hidden layer input, the RNN block, sorry. The RNN block takes the input from the previous time intervals hidden layer output and output from the previous time intervals. So once it gets that out, both things, it passes their outputs to a softmax layer, which it actually computes the loss, and then it generates the sampled output. So it continues till the end. Now, what are the difference that they made? So that the difference they made, like instead of directly passing output to the next as an input to the next layer, or directly passing the ground truth input to the next layer, they have applied a sampling strategy here. So they have both things like sampled output from the previous layer, previous timestamps, and the ground truth also. They all provide both with a flip kind of sampling strategy, selection strategy. And Same way they do with all the stages. And which one will be used as an input is decided through this flip a coin kind of strategy. So, and again, the entire computations depends upon the some probability epsilon. So they set those epsilon's value such that at the starting stage the system will take the ground truth, but later stage or at the end of the algorithm the system will start using their own output, previous output, as an input to the next stage. Means system became independent from the teacher forcing strategy, but they, as at the starting they use the teacher forcing, so they have positive side of teacher forcing, and they, with the sampling and then flip coin strategy, they have removed the drawback of teacher forcing. That's why it is working better than teacher forcing. Now you might be thinking like how the authors have made the arrangement so that at the initial stage of training the scheduled sampling will use the ground truth, and at the later stage like ground truth like teacher forcing, and at the later stage or final stage of training it will depend upon the sampled output from the previous stage. So how it is possible? So what is flip a coin? So flip a coin is nothing but this is a case, two cases. Like this depends upon some probability epsilon. So if epsilon I equal to 1, we use it like a teacher forcing. Means we use like a ground truth of each of the output. So this may be the initial stage, very initial stage of the training. After that, authors applied some decay process. It will reduce the value of epsilon. So at the later stage or at the final stage, near to the final stage, when epsilon I will be equal to 0, then the training will be depend upon the predicted values. So in this case, to calculate the decay, speed of the decay, like how to decide when to shift from this to this, to decide that authors have proposed 3 kind of decay functions like linear decay, exponential decay, inverse sigmoid decay. So in the linear decay, epsilon I is calculated as maximum of epsilon and k minus ci, where epsilon's value depends upon lies between 0 and 1, and k is the offset and c is the slope of the decay. And exponential decay, this is calculated by k to the power I, where k depends upon the expected speed of the convergence. So based on the value of k, the value of epsilon I is calculated. Now the third is inverse sigmoid decay. So in the inverse sigmoid decay, the authors have computed the value of epsilon I through k divided by k plus exponential of I divided by k, where k is greater than 0, greater than or equal to 0, and here also k depends upon the expected speed of convergence. So if you see the actual diagram that is provided by authors in this paper, you will see that how after some time the value will go down in both cases, in all 3 cases, and how the system shifts from the teacher forcing type of scheme to the sample, means becomes independent on the training. So due to such kind of arrangement, what happens, the system at the test time, its dependency on the ground truth has been removed. Means it is not at the test time, it will not be dependent upon the ground truth. So that's why this is performing better than the traditional teacher forcing. In the next section of similar kind of tutorials. I will try to cover professor forcing and all other latest forced learning kind of strategies that people applied to direct the deep learning training and test strategies. So thanks for watching.